Today we're solving LeetCode 1266, minimum time visiting all points. This is a deceptively simple problem that tests whether you can recognize movement patterns instead of simulating everything. It's common in interviews because the optimal solution looks too easy. If you see the insight, you're given a list of points on a 2D grid. Each point is X, Y, and you must visit them in order. In 1 second, you can move up, down, left, or right by 1 unit, or move diagonally by 1 unit in both X and Y. Your task is to return the minimum number of seconds required to visit all points. Example 1. Input: an array containing 3 coordinate pairs. The first is 1, 1, the second is 3, 4, and the third is -1, 0. Step 1. From 1, 1 to 3, 4, the x distance is the absolute value of 3 minus 1, equal to 2, and the y distance is the absolute value of 4 minus 1, equal to 3. You can move diagonally twice. We move from the point 1, 1 to 2, 2, and then to 3, 3. Then move up once. We move from the point 3, 3 to the point 3, 4. Total time equals to 3 seconds. Step 2. We move from the point 3, 4 to the point -1, 0. The distance in the x direction is the absolute value of -1 minus 3, which is 4. The distance in the y direction is the absolute value of 0 minus 4, which is also 4. You can move diagonally 4 times. Total time equal to 4 seconds. So the final answer is 3 plus 4, which equals 7. This problem is about movement geometry, not simulation. Key insight: when moving between 2 points, the minimum time required is max of absolute x2 minus x1, absolute y2 minus y1. Why? Diagonal moves reduce both x and y at the same time. You should always use diagonal moves as much as possible. Once one axis is aligned, you move straight on the other axis. This pattern shows up often in grid problems. It's not BFS. It's not DP. It's a greedy distance calculation. Let's try a brute force approach. A brute force idea might be: simulate each second. Decide which direction to move at every step. Update position until you reach the next point. This works logically but is completely unnecessary. Why? It's inefficient, adds complexity, harder to reason about, more room for bugs. Interviews expect the mathematical insight. Can we optimal the solution? Yes, we can. For every consecutive pair of points. First, compute dx as the absolute value of x2 minus x1. Next, compute dy as the absolute value of y2 minus y1. Then, add the maximum of dx and dy to the total time. Now, why does this work? We can take the minimum of dx and dy diagonal moves, since each diagonal move reduces both coordinates by 1. After that, the remaining difference, which is the absolute value of dx minus dy, must be covered using straight moves. When you add these together, the total time is simply the maximum of dx and dy. We repeat this for all adjacent points and sum the results. We define a class called solution. Inside it, we define a function named minTime to visit all points, which takes a list of points as input and returns an integer. We start by initializing total time to 0. Then, we loop from index 1 to the end of the points list. For each step, we take 2 consecutive points. The previous point gives us x1 and y1, and the current point gives us x2 and y2. We compute dx as the absolute value of x2 minus x1, and dy as the absolute value of y2 minus y1. Since we can move diagonally, the minimum time to travel between these 2 points is the maximum of dx and dy. We add this value to total time. After processing all points, we return the total time as the final answer. This code is short, readable, easy to explain verbally in an interview. Time complexity: O of n. 1 pass through the points. Space complexity: O of 1. Only variables for tracking distance. Here are some common mistakes to watch out for. First, using Manhattan distance, which is dx plus dy, instead of taking the maximum. Second, trying unnecessary BFS or simulation, which overcomplicates the problem. And third, forgetting that diagonal movement is allowed, which is the key to solving it efficiently. Finally, let's consider some edge cases. If there is only one point, the answer is simply 0, since there's nowhere to move. If points have negative coordinates, that's handled naturally by the absolute value function, so no extra work is needed. Let's recap. This problem reduces to computing distances between consecutive points. The key formula is the maximum of the absolute difference in x and the absolute difference in y. There's no need for simulation, BFS, or dynamic programming. Here's an interview tip. If a problem allows diagonal movement, always ask yourself, can I move in multiple dimensions at once? That question often leads directly to the optimal solution. Thanks for watching, and I'll see you in the next problem.